Very good evening, dear students. Today's topic is velocity potential and stream function. So first, velocity potential function. What is velocity potential function? So it is defined as a scalar function of space and time such that its negative derivative with respect to any direction gives the fluid velocity in that direction. It is defined by phi. Mathematically, the velocity potential is defined as phi is equal to function of x by z for steady flow such that u equal to minus del phi upon del x, v equal to minus del phi upon del y, and w equal to minus del phi upon del z, where u, v, and w are the component at velocity in x, y, and z directions respectively. The velocity component in cylindrical polar coordinates in terms of velocity potential function are given by u suffix in suffix r, which is equal to del phi upon del r, and u theta is equal to 1 upon r into del phi upon del theta, where u r is the velocity component in radial directions, that is in r direction, and u theta is the velocity component in tangential direction, that is in theta direction. The continuity equation for an incompressible steady flow is du upon dx plus del v upon del y plus del w upon del z is equal to 0. Substituting the value of u, v, and w. So we get del upon del x in bracket of minus del phi upon del x bracket close plus del upon del y in bracket of minus del phi upon del y in bracket close plus del upon del z in bracket of minus del phi upon del z, which is equal to 0. Again, del square phi upon del x square plus del square phi upon del y square plus del square phi upon del z square, which is equal to 0. This equation is known as Laplace equation. Second, stream function. What is stream function? It is defined as the scalar function of space and time such that its partial derivative with respect to any direction gives the velocity component at right angles to that direction. It is denoted by sign and defined only for two-dimensional flow. Again, I repeat, it is defined only for two-dimensional flow. It is valid only for two-dimensional flow. Mathematically, for steady flow, it is defined as phi equal to function of x by such that del psi upon del x is equal to v and del psi upon del y is equal to minus u, where u and v are the velocity in x and y directions respectively. The velocity component in cylindrical polar coordinates in terms of stream function are given as ur equal to 1 by r del psi upon del theta and u theta equal to minus del psi upon del r, where psi is the stream function and ur is the radial velocity and u theta is tangential velocity. The continuity equation for two-dimensional flow is del u upon del x plus del v upon del y equal to 0. Substitute the value of u and v in this continuity equations. So we get del upon del x in bracket of minus del psi upon del y plus del upon del y in bracket of del psi upon del x equal to 0, or minus del square psi upon del x into del y plus del square psi upon del x into del y equal to 0. Hence, existence of psi means a possible case of fluid flow. The flow may be rotational or irrotational. The flow may be rotational or irrotational. The rotational components omega z is given by omega z is equal to half of del v upon del x minus del u upon del y, where u and v are the velocity component in x and y direction. Substituting the value of u and v, so we get omega z is equal to 1 half or half in bracket of del y del x in bracket del psi upon del x bracket close minus del upon del y in bracket minus del psi upon del y whole bracket close, or we also write this omega z is equal to half in bracket of del square psi upon del x square plus del square psi upon del y square. We know that for rotational flow omega z is equal to 0. Hence above equations becomes as del square psi upon del x square plus del square psi upon del y square equal to 0. This is del square psi. And this equation is also Laplace equations. The properties of stream functions are First is if stream function exists. If stream function exists, it is a possible case of fluid flow which may be rotational or irrotational. Second property of stream functions is if stream function satisfy the Laplace equation, it is a possible case of an irrotational. I repeat, if stream function satisfy the Laplace equation, it is a possible case of an irrotational flow. And Laplace equations del square psi upon del square psi upon del x square plus del square psi upon del y square is equal to no. So it is above. Okay. So I hope आपको clear हो गया होगा what is stream function and what is velocity potential functions. So thank you so much. lecture इतना ही sufficient.